Example work-through using negative exponents. Here we have 4 examples, all using the directions of writing with only positive exponents, getting increasingly more complex, all involving negative exponents, using combinations of different exponent rules. Let's start with our first one. Remember, a negative exponent just means your term is in the wrong spot of a fraction. So first, we have an exponent outside of parentheses, so the -2 will distribute in and multiply by each of our existing exponents. Always start with that fraction bar to help keep things organized. For right now, our x's will stay on top and our y's will stay on bottom. When we have stacked exponents like this, we multiply, so our exponent for our x's becomes 2 times -2, which is x to the -4, and our exponent for y's is 3 times -2, which is y to the -6. Now remember, our direction said writing only positive exponents, so both of these will need to switch. Our x is currently on top, and the -4 means it's unhappy where it's at, so it needs to move to the bottom. Where our y has an exponent of -6, meaning it's unhappy on the bottom, so it needs to move up to the top. So in short, our x and y's just switch places, but notice both of the exponents switch to positive because now they're where they're supposed to be. And that's our final answer for the first one. For our second example, we don't start with a fraction, but we do still have an exponent outside of parentheses, so our -4 needs to multiply into each of these exponents. Don't forget the invisible one on the z. Our x becomes 2 times -4, which gives us x to the -8, and for our y's we get 3 times -4, which is y to the -12, and lastly for our z's we get 1 times -4, which is just z to the -4. Again, we want positive exponents, and imagine these like a fraction over 1, where all of our variables are on the top and in the wrong spots because they're negative, so all 3 will need to move to the bottom of the fraction in order to become positive. And again, as we move these variables to the bottom of the fractions, all the signs for the exponents will change from negative to positive. Invisible 1 was multiplying, so that invisible 1 is left behind, and this becomes our final answer. Now for this example, we're getting a little bit more complicated. First, we've got coefficients. We've also got 2 types of variables. We have negative exponents on the top of the fraction, and we have a stacked exponent on the bottom of the fraction, so this 2 will need to distribute. All have invisible 1s as exponents, so when our 2 distributes in, it will multiply by each of those 1s. However, since 1 times 2 is just 2, each of these terms will basically just get a 2 as an exponent. When starting an example like this, you can either start with the top of the fraction or the bottom, up to you on which you feel more comfortable with. I personally like starting with the stacked exponents on the bottom. First, draw the fraction bar, and everything up top won't change yet. All we're doing on the bottom is distributing that 2 in, and as we said earlier, 2 times 1 is 2, so all of these will get 2 as an exponent, which means it will look like this. One thing about these simplifying the exponent expressions is as we get more complicated, there are many different ways you can approach it, so most of the time it just really depends on how you like to approach it. For instance, simplifying our 2's out here, you could think of it like the quotient rule, where we have 2 to the 1 minus 2 to the 2 on bottom, or you could multiply out this 2 squared to get 2 times 2 is 4, which is personally how I like to do it because then we're just simplifying this fraction, and to simplify we would just divide both by 2, which would give us 1/2 for our answer for the coefficients. Similarly for the w's, we could think of this like the quotient rule, where you would end up with -3 minus 2, which would give you w to the -5, and that -5 would mean the w would go on bottom. However, subtracting with negatives can sometimes be confusing, so I prefer to look at this like first moving the negative exponent down to the bottom, which would give us w to the 3 times w to the 2 on the bottom, which means we would add those exponents to end up with just w to the 5 on the bottom. Now if we use that same idea with our x's, our x to the -2 would want to move to the bottom, and when we move it to the bottom it switches to positive, which would mean we'd have 2x squareds on the bottom, which we would combine by adding the exponents, leaving us with x to the 4 on bottom. And then this would be our final answer. We can clean it up a little bit just to make it look nicer. For our final example, we have coefficients, we have m's, remember the invisible one, we have n's, and we have this p. For our coefficients, we just divide like normal, so this becomes 36 divided by 4, which is 9, and since our bigger number is on top of the fraction, our answer will go on top of the fraction. You can do these in any order that you want, starting with our m's and using the logic from the previous question. These m's to the -4 want to move to the bottom to become positive. The 1 m that was on the bottom will now combine with the 4 that joined, give 5 m's on the bottom. Same idea for our n's, but the opposite. Our 2 n's from the bottom want to move up to the top, and they will join the 6 n's that were already up there to give us 8 n's up top. Our p's are on bottom right now, but the negative exponent says move them up top, and since there are no p's up top, it will simply just switch to positive. So we get p to the +4 up top, and there's our final answer. As always, thanks for watching. I hope that all made sense. Subscribe to the channel for more examples, and please share this with anyone you think might find it helpful.